back to another professional prep video. So in this video, I'm going to start out with a short introduction to the unit circle. So please pardon my circle drawing abilities, but here we have a circle, and let me just make sure the ends meet there. But essentially all I'm going to do here, I'm just drawing a circle, and then I'm going to take a quick look at it to see what we can glean from that circle. That should be better. Yep, that should be good. So here, let's call this point the center. And let's say that our center is at the origin. Actually, better yet, let's say that our center is at the point h comma k. That's standard for the equation for circles. So that standard equation for circles, I should say. And then let's say that our radius is of length r. So what we have here is the unit circle. The standard typical unit circle has a center at the origin and a radius of length 1. And what we can figure out a lot about the coordinates going along these. So if we move this radius up here, this should be a perfectly vertical line. Then this is the 90-degree mark. 0 degrees, 90, 180, 270, back to 360. Because every circle has 360 degrees total. So for this little angle that we've created here, this is a 90-degree angle. This covers 1/4 of the area, 1/4 of the arc length, of the total circumference of the circle. We understand those concepts. For the unit circle, what we need to know is that this point right here, we can actually figure it out using simple trig functions. So what do I mean when I say simple trig functions? Just sine and cosine. So for a standard unit circle with a radius of 1 and center at the origin, cosine theta comma sine theta would be the coordinates at any point. Theta being the angle that's created between this horizontal radius and the other one. So in this case, this one would be 90 degrees. If we went here, maybe we'd be more like 135 degrees. That angle in between these two radii here. So cosine theta, which is also known as the central angle, by the way, just to clarify that. So cosine theta, sine theta. Pardon my writing. And so let's start here. So we want to figure out the coordinates of this point, assuming that this radius is of length 1 and h comma k is 0 comma 0, aka the circle is centered at the origin. So what we can do is this would form a 0-degree angle, and what we can do is to figure out these coordinates using this, obviously we might know just from simple algebra that this is going to be 1 comma 0, but let's use properties of the unit circle to figure that out. So this is at the 0-degree mark. So the coordinates of that point right here is going to be cosine 0 comma sine 0. We know that cosine 0 is going to equal 1, and that sine 0 is going to equal 0. And sure enough, that gives us 1 comma 0. Likewise, we could do that for 90, 180, and 270, but we could also do it for some middle angles here. So for example, let's take a look, just to do one more example, at the 45-degree angle. So that's going to look a little something like this. So I know that line isn't fully straight, but let that be 45 degrees. Cosine 45 is going to equal root 2 over 2, which we know from trig and geometry. If not, you can just draw an isosceles right triangle, and it's pretty easy to derive from there. Simple, I should say. Root 2 over 2, and sine 45 is also going to equal root 2 over 2, since, like I said, this would be a right isosceles triangle, making the two legs equal. And that actually gives us the coordinates of the point when we extend the radii for a 45-degree angle. That gives us the coordinates of this point. This point has coordinates root 2 over 2, comma root 2 over 2. So that's pretty cool because we can plug in theta to get any point on the circle. So you might be asking, what if r is not 1? Or what if h comma k is not the origin? So then the general form would be r cosine theta, and you might recognize this from polar equations if you're familiar with those. If you're not, no worries, you don't need to be. But that would be r comma 0, or r cosine theta, excuse me. And then what you can do is you can add the origin point. So, or add the center point, I should say. So not 0 comma 0, we're at h comma k, and this is for the x coordinate, of course. Cosine corresponds to x, sine corresponds to y. That's important to note. Then we can do r cosine theta plus h, comma r sine theta plus k. And that will get us our coordinates. And just taking a look at this right now, if we plug in 0 for each of these, and we have an r equals 4 with a center at, so let me write this, r comma 4 and a center of 4 comma 3. And we want to find the 0 degree angle right here, and we plug that in. We're going to get cosine theta, that's going to be 1. And that's going to give us, oh, excuse me, sorry, this should be r sine theta plus k. Sorry about that. Must have forgotten to write that in. Let me erase that just so that we avoid confusion. But yeah, essentially you're adding on the coordinates of the center, r sine theta plus k. So if we plug this in, cosine 0, 1 times r, which is 4, so we get 4, plus h, which is 4 here, which becomes 8, and sine 0 is 0. 0 times anything is 0, so we don't need to worry about r, plus k. K is 3, which gives us 8 comma 3, which just by observation you can tell is correct, because with a radius of 4, you should just be adding on that radius to the x-coordinate, and there should be no vertical shift here, and sure enough, there is not. So that's a basic introduction to the unit circle. Make sure you let us know if you have any questions, and if not, we will see you next video. Thank you very much, everyone.